In this video, I will talk about 4 important formulas that are used to find the derivative of a function using the limit definition. So if we have f of x a function and f of a point on the graph of f. So when we write a point on a graph, we write it in the format f of a with parentheses that represent the first position, it's the x, and the second position, it's the y in the coordinate plane. The first formula says f prime of a equals limit as x is approaching a of f of x minus f of a over x minus a. This is the derivative of a function at a point x equals a using the definition of a derivative. F prime of the second formula, which represents exactly the same thing, the derivative of a function at a point a, using the definition of a derivative, is f prime of a equals limit as h is approaching 0, of f of a plus h minus f of a over h. This is the answer that we get, it's exactly the same as using the first formula, but the limit is in a different format. The third formula is f prime of x. So the difference between 1, 2, and 3 is that this time I'm calculating the formula at any point x. So not just for a specific value, like for a 2 or a half, like we do in 1 and 2, but in general. So the formula is limit as h is approaching 0 of f of x plus h minus f of x over h. So formula 3 is very similar with formula 2, only this time instead of calculating for a specific point, we are calculating on the whole domain of x. This is the derivative at any point x using the limit definition. So basically, you can use this formula anytime you want to calculate the derivative of a function. Again, it's using the definition because later you're going to learn to calculate this using rules of differentiation. And the fourth formula is y minus f of a equals m times x minus a. This is the equation of a line in point slope form, and what it actually gives us is the equation of the tangent line to the graph at a point. So for example, if your graph looks like this and you just calculated, let's say this is a point A and this is f of a, this line here is the tangent line to the graph, and this relation that we wrote in part 4, it's the equation of this tangent line, where m is given by the formula limit as h is approaching 0 of f of a plus h minus f of a over h, and it represents the slope of the tangent line. So to find the slope of the tangent line, we can use formula 2 to find that. I hope this helps.